I welcome you today to my podcast. I want to speak to you on the topic that I have titled the concept of time as a non-linear construct. The concept of time as a non-linear construct. Today I want to explore with you the fascinating and perplexing concept of time as understood through the lens of quantum physics. You see, for centuries, philosophers, scientists, and even spiritual seekers alike have grappled with the nature of time and its relationship to the human experience, if it's okay for me to put it that way. But in the realm of quantum physics, we begin to glimpse a reality that defies our traditional understanding of linear time. First, let us consider the familiar concept of cause and effect. In classical physics, we are taught that every effect has a clear and measurable cause. For example, when a cue ball strikes a stationary billiard ball, we can predict with near perfect accuracy the direction and speed of the second ball's motion. But in the quantum world, things are not so straightforward. Okay? Here, the act of observation itself can influence the behavior of subatomic particles, such as electrons. This principle, known as the observer effect, suggests that the very act of measuring or observing an object can affect its behavior. This leads us to the concept of supposition, which states that a particle can exist in multiple states simultaneously until observed or measured. In other words, a particle can be in two or more places or states at once until we interact with it. This phenomenon challenges our traditional understanding of cause and effect, as it suggests that the future behavior of a particle is not predetermined, but rather depends on the act of observation. Furthermore, the theory of relativity, proposed by Albert Einstein in the early 20th century, suggests that time is not a fixed and constant entity, but rather a relative concept that is dependent on the observer's frame of reference. So, for example, time appears to move more slowly for an object in motion relative to an observer at rest. This theory further underscores the notion that time is not a linear construct, but rather a fluid and relative one. So, my friend, what does all of this mean for us as human beings? Well, for starters, it challenges our notion of free will and determinism. If the future behavior of particles is not predetermined but rather depends on the observation, then perhaps the same can be said of human behavior. Perhaps our choices and actions are not predetermined but rather influenced by observations and interactions with the world around us. Furthermore, this understanding of time challenges our attachment to the past and our preoccupation with the future. You see, in the quantum world, the past and the future are not fixed and immutable, but rather constantly in flux. This suggests that we should focus our attention on the present moment, as it is the only moment that truly exists. However, this understanding of time is not without its challenges and criticisms. Some critics argue that the concept of supposition and the observer effect are limited to the quantum world and do not necessarily apply to the macroscopic world of everyday objects. Others argue that the theory of relativity, while revolutionary in its time, may not be the final word on the nature of time and space. Despite all these challenges, the insight provided by quantum physics can offer a new and refreshing perspective on our relationship with time. It challenges us to let go of our preconceptions and assumptions about the nature of reality and to embrace the fluid and relative nature of existence. As a great philosopher and writer, Alan Watts once said, anyway, Alan Watts is a kind of mentor to me. The only way to make a sense out of change is to plunge into it, move with it, and join the dance. You see, so we have to embrace the dance of time and revel in the mystery and wonder of the universe. I mean, the implications of quantum physics go beyond our understanding of time and space. They challenge our fundamental assumptions about the nature of reality itself. I mean, in the quantum world, particles can exist in a state of entanglement where the behavior of one particle is linked to the behavior of another particle, even if they are separated by vast distances. This phenomenon challenges our notion of separatedness and suggests that everything in the universe is connected in ways that we cannot fully comprehend. The interconnectedness also has profound implications for our relationship with the nature of things, or at least with the natural world. We suggest that our actions and choices have a ripple effect that extends far, far, far beyond our immediate environment, and that everything we do is intimately connected to the world around us. Before I end this, I want you to know that the concept of time in quantum physics challenges us to rethink our relationship with time and space and to embrace the fluid and relative nature of existence. Challenges us to let go of our preconceptions and assumptions about the nature of reality and to embrace the mystery and wonder of the universe. It challenges us to recognize our interconnectedness with all things and to act with mindfulness and compassion in everything we do. You are not a drop in the ocean. You are the entire ocean in a drop. You are not a drop in the ocean, but you are the entire ocean in a drop. Thank you. Thank you. And I love you.